I would like to show you how to account for qualitative information in the regression. For example, we have information on the zone here. From the data description sheet, we learn about the meaning of those different codes. And if we have, in this case, 5 different areas and types of areas, we can create out of those 4 different so-called dummy variables, and one of the categories is left out, has to be left out, and this will serve as the so-called reference category. We choose the commercial area as a reference category. The first dummy variable is created as follows. This would correspond to the floating village residential area, and this values would be equal to 1 if that entry here equals FV. The next dummy we create is for high density, so this will be 1 if this would be RH, and we have a zone medium, and that will be, that's equal to RM. And the final one will be the low L, that's equal to RL. Alright, so we have 4 variables here, 4 additional variables. The interpretation I will explain once we've obtained the regression results. And now I will choose the regression add-in again, pick regression. I will say here's the sales price as the input for the Y range, and now we'll have X data, X range. Now starting with the 4 dummy variables, we are also going to include the lot area and the 4 that we already have. And we've included the labels, and the output will be written, say, over here. And so here we get the regression results. A quick comparison. We've slightly improved the multiple R, slightly improved the R square, and the standard error has gone slightly down from something like $38,000 to $37,000. So the information from those 4 additional, or actually 2 additional variables, because the source of information that we use is zone, it has been just split up into 4 pieces here, and the lot area. They don't really contribute a lot to the explanation, and but that's typical for multiple regressions. You move on step by step. You hope that the additional information you introduce adds value in the sense of providing a better fit. But it's a process that works in steps, and you would try to figure out step by step which additional variables contribute significantly. So in terms of interpretation, let me first interpret the 4 coefficients that we obtain for those 4 categories. As I said before, the commercial area has been used as a reference category. So for instance, this ZVFV variable would mean that compared to a house in the commercial area, houses in the floating village residential area have an expected additional price of about $7,000, provided other features are held constant or are the same. So for houses in the same quality, same conditions, same age, same size, essentially, if they're located in this floating village residential area, on average their price would be about $7,000 higher than in the reference category commercial area. For the high density variable, we find the price to be about $12,000 higher than in the commercial, in medium about $1,600, and for the low density $7,000 higher than in the commercial area. So what you could also do with these coefficients from dummies would be you not necessarily need to compare to the commercial area. You could also say that houses in the low density area have a price which on average is about, let's say, compare it to the high density area, about $5,000 higher. So the difference between those two coefficients would measure the price effect of a house in a low density area versus a high density area, provided other factors are held constant and leave us with comparable houses. In terms of the t-stats, we see that the information from those dummy variables is rather imprecise. So we're not getting very precise estimates for the effects of comparisons of houses in different locations. So this is essentially saying it's hard to distinguish houses based on their location, at least for this data set. What this, of course, what we have to bear in mind is that all these four coefficients are relative to the commercial area. So essentially it says that it's hard to distinguish house prices between those areas that we listed here and the commercial area precisely enough. So that's a low t-statistics information that we get. For the remaining areas, we see t-statistics are high, above the rule of thumb value of 2. The lot area would also contribute significantly. But what we also see from this table is that despite the fact that we have added now lot area as an additional variable that has a relatively high t-statistic, this does not necessarily mean that the other measures for the goodness of fit dramatically change.